Hello and welcome back. My name is Amir and this is Project Euler series. We're going to solve puzzle number 39 today. So let's go and see what we are facing. Integer right triangles. If P is the perimeter of a right angle triangle with integral length sides A, B and C, there are exactly three solutions for P equals 120. And these are these three solutions. So we should remember that a right triangle is always like this: a squared plus b squared is always equal to c squared in a right triangle. And for each and every triangle, whether it's a right triangle or not, a plus b plus c is equals to b. This is the formula for perimeter. So for which value of p less than 1000 or equal to 1000 is the number of solutions maximized. So having these two can help us. We would go for a from let's say 1 up to 1000, and then b from a to p minus a. So, we can go a b from 1 also, but we assume that a is less than or equal to b, which is less than or equal to c. We assume this, and that's fine. We can change the position of a and b, and nothing changes in these formulas. So that's why we go from a all the way to p minus a. So if we say that we have reached a p which is 100 and our a is like 25, one of the iterations in this, then our b would be going from 25 up to 75. That's the maximum that it can go, because 25 plus 75 is 100 and the c will be 0, which we don't want. And then we can calculate c using this formula, and then we would check that if a squared plus b squared is equal to c squared. Right? So let's go and write the code. I will have two variables: max perimeter, so the maximum perimeters that we have found, and the maximum of triangles. This is 0, and this one is also 0. So this is our main for loop. We're going from 1 to 1000 and calculate it, but we need to do the calculation. So So here again, we're going from 1 to p minus 1 and b from a to p minus a. And we get the c based on the formula of the perimeters for each and every triangle. And then we would see that if b is less than the c that we calculate here, and this formula is correct, then we would add the count, and in the end we will return count, and here we check that count that has been returned from this function here with the maximum that we have already found, and if this is bigger, then we store the max triangles and get the max perimeter. So let's go and see if this is working fine or not. Yes, this is the correct answer. I hope you have enjoyed the video. The code is in my GitHub channel, and see you in the next video.